Hi, and welcome to another Forest Service web tutorial. My name is Mariana Dobre, and I'm a research scientist at University of Idaho, working on the development side of WEPPcloud. In this video, we'll learn how to select managements and soils. Selecting the land use is a fairly simple process, as you only have two options available: to determine by hill slope or to use a single land use for the watershed. For undisturbed conditions, the land use will be assigned from a list of WEPP management files that reside on the interface and are selected based on the 2016 National Land Cover Database. To demonstrate this, I will start with a model run that I previously ran for undisturbed conditions. From the upper right corner, we have the option to change the default base map from terrain to the 2016 National Land Cover map. Now, if you switch between default and dominant land cover, you get an idea of what the interface is selecting for each of these hill slopes. For each hill slope, you might have one or more types of land covers or managements. In this undisturbed model run example, this particular hill slope is covered mainly by forest, but it is also covered by shrubs on a small portion. In cases where a hill slope is covered by multiple land covers, the interface will assign a management based on the most dominant land cover. In this example, the dominant land cover is forest, and the interface assigned it a forest management. Similarly, for this other hill slope, we see from the 2016 land cover database map that the dominant cover is shrubs, and that WEPP assigns a shrub as a dominant management. For disturbed or wildfire conditions, I have here a run that I used in a previous video to delineate the watershed. So let's go ahead and build managements by hill slopes. While in the undisturbed run, we only had two land covers, forest and shrubs, in the wildfire simulation, we have the same two categories, but split by soil burn severity. The low, moderate, and high severity categories are in fact areas covered by forests where soils burn at a certain severity, while the shrub low and shrub moderate are hill slopes covered by shrubs that burned at low and moderate severity respectively. The most critical management parameters for soil erosion in WEPP are canopy cover and rill and interrill ground covers. If the soils are 100% covered by vegetation or pine needles, there will be almost no erosion. But if the ground cover decreases due to forest management or wildfires, there will be an increase in erosion. If you click on this wrench, you can see the canopy cover and the rill and interrill cover default values, which you can easily modify. We recommend you modifying these values based on the information you have from your watershed. For example, if a moderate severity fire left a canopy cover of 50%, then you would change this value to 50. And similarly for the rill and interrill covers. These are not the only vegetation parameters in the model. If you click on the land cover key, you can open the actual management file used by the WEPP model. You can see here many vegetation-related parameters. For advanced users that want to fully understand these parameters, we recommend you to consult the WEPP user manual at page 32, where you can find line-by-line information on these parameters. For example, the first three lines are WEPP version, number of overland flow elements, and total number of years in a simulation. If we go back to the management file, we see that the WEPP version is 98.4 with one overland flow element and 1 year of simulation. We are using a newer version of the WEPP model, but these managements were built under version 98.4, which is why you see this number on line 1. To build the soils, the interface is accessing both the Sergo and the StatsGo databases, and then builds a soil file in a specific format required by WEPP. Sergo is used as the default option, but the interface will access the StatsGo database where the Sergo soils are missing. Similarly, as for the managements, we have the option to determine the soils by hill slopes, or we can use a single soil based on the map unit key or MU key, or we can select the soil from a provided database. Most of the times we will select to determine the soils by hill slope, in which case the interface will build WEPP soil files from the available information in the soils database. The initial soil saturation option is only useful for the single storm model runs, and we will talk about it in the video on selecting the climates. After building the soils, you can see a list of all the soils by map unit, which is taken from the Sergo database, a description of the soil, and % coverage. If you open one of the soil files, you can actually see all the soil properties. The first lines marked with a hashtag are comments, and the soil file starts from 7778, which is the version of the soil file. In the comment section, you'll find more information regarding any missing data from the Sorgo StatsGo databases and the default values that were used instead. I will not go into details regarding the soil parameters, but if you're interested in understanding what these values are, I recommend you to open the file in the actual web model and read the example soil file 7778. Once you open it in WEPP, you can see all the soil properties by soil depth. And then you can open the actual soil file from the WEPP folder in your computer, navigate to Data, Soils, and scroll down to example 7778.sol file. Now you can actually see that this is a loamy sand soil, that the first column is soil depth, the last column is percent rock, and that we have a restricting layer with the hydraulic conductivity of the underlying geology of 0.0042 millimeters per hour. Sometimes we alter these soil parameters to calibrate the model in certain regions, so it's good to know where you can find more information on these files. If you need to change any of the soil properties, we have recently added an option in WEPPcloud to allow you to make these changes. You can do this from the Power User panel, Modify Disturbed Parameters. Once you click here, then you will be redirected to a database that contains default values for some of the soil properties. These are organized by disturbed class and texture. From here, at any moment, you can only change the first 6 parameters. These are albedo, which is not a very sensitive parameter in the model, initial soil saturation as fraction, which you can also change from the main page, inter-real erodibility and real erodibility, critical shear, and effective hydraulic conductivity. Now, let's pick a soil and increase the real erodibility for the low severity fire. Let's select the low severity fire silt loam soil. In the comments, we can see that this is indeed a soil with a silt loam texture that burned at the low severity fire. Here we have the inter-real erodibility, real erodibility, and critical shear. And let's say we want to increase the real erodibility. We go back to the table and find the forest low severity and change the value to 0.0002. Then scroll all the way down and click Save My Changes, and then return to the main page and rebuild the soils. If we now reopen the soil, we see that we have the erodibility we have provided. Again, you have the option to change these values, but change them only if you have a good justification. Usually, most of the default values you see on the interface are taken from field research data. This is not to say that the default values can be wrong, but it's good to have a justification for any change you make. You also have the option to change the managements. And there are 2 ways to do this. First option is to change the managements from the drop-down menu, and you replace, let's say, a moderate severity with cable thinning, which will change the canopy cover to 40% and the ground cover to 93%. Another way is to change the management for specific hill slopes only. If you scroll up to the map, you can find a wrench that will allow you to modify these managements by hill slope. I usually like to remove the hill slope and the channel IDs so you can better see the hill slopes. Now you can click on specific hill slopes and then select the land use from the drop-down menu to replace the management. Let's select the thinning treatment and then click Modify Land Use. Note that there is a message instructing us to rebuild the soils after changing the managements. So let's go back to the soils and rebuild them. Now you can see that some of the slopes have soils that have also been altered to reflect thinning conditions. If we want to visualize the hill slopes with the new managements, we go back to the map and click on the 4 stacked squares and select Dominant Land Cover. This will display the hill slopes with the new thinning managements. And similarly, you can also visualize the soils. When we change these managements and soils, we're really using the default forest management files or the soils with the soils properties from Surgo, and only changing key parameters that would be affected by a particular management. For example, we are changing the canopy cover and real and interreal ground covers for the vegetation, and the soil hydraulic connectivity, critical shear, and the real and interreal erodibilities for the soils. That's all on building managements and soils. Next, we will talk about building climates.